Okay, so here we have another equation to solve. And this time they wrote the domain just a little bit different. They used the interval notation. And I just wanted to point that out because sometimes I use it. So this means the same thing as 0 is less than or equal to, in this case, x is less than 2 pi. Okay, so it means the same thing. It's just written in interval notation. Okay, so I spent some time on this problem because I looked at it and I said, well, you know, we're going to do a different technique for this problem, but why not just use the double angle formula like we did, you know, in a previous example? You could do that. I used the one with sine squared, and it works out just fine. But what if this 2 had been something like a 5 or some other number that wouldn't have been like a double angle formula? We have another technique, and so I'm going to show you on this example. All right, so let me erase that stuff. Okay, so what we're going to do is we're going to say cosine 2x equals 1/2. Well, we know where cosine is 1/2. Okay, so we can say something like if it were cosine alpha equals 1/2, we would know the answers. Cosine alpha equals 1/2. You're going to be positive in the first and the fourth quadrants. And these are special angles. It's going to be pi over 3. I feel like we've used that one a lot. And then it's going to be the one down here, which is pi over, 5 pi over 3. Okay, let me make sure I get those right. So alpha would be equal to pi over 3 and 5 pi over 3. Now you might be wondering, well, why do you have that alpha in there? Well, I'm just saying, you know, pretend like this 2x is just some angle. And because I know the cosine of some angle equals 1/2, I can solve for that angle. And this is what I get. Now, the problem is we don't have alpha, though. We have 2x. So we're saying 2x equals pi over 3 and 5 pi over 3. And then we can divide them both by 2. So, or multiply by 1/2 if you want to think of it that way. So think about multiplying by 1/2, just, you know, like solving. I have two answers. I'm just doing them both at once here. But you would get x equals pi over 6 and 5 pi over 6. And you might be happy, and you might say, hey, that's great. That works. They're both in the domain between 0 and 2 pi, both pi over 6 and 5 pi over 6. The problem is there are more solutions. So how do you know? Okay, so when we did it this way, where we said, okay, well, think about it in terms of alpha, but we have 2x, that means everything's getting cut in half. What it means is we need to double the domain. We need to go a second time around, okay? So we have one solution. Let's go back to this one here. So we were saying 2x equals pi over 3. Now I'm just going to do the 1. But then let's go another time around the circle. Add 2 pi to that. Okay, well then because we know that, you know, in theory you could keep going around the circle. They just restricted our domain to 0 to 2 pi. But watch what happens. We get 2x equals, so you're going to have 6 pi over 3 or 7 pi over 3. But then when you divide by 2 or you multiply by the 1/2, you get pi equals 7 pi over, not pi. I keep changing my x. Goodness sakes. Get that out of there. This was supposed to be an x. Okay. X equals 7 pi over 6. 7 pi over 6, that's in the range. It's over here. And so that is between 0 and 2 pi. So this is a solution right here. So we found another one by adding 2 pi. You might say, well, okay, what if I were to take 2x? I did it again, geez. Okay, 2x, what do I get for working early in the morning? 2x equals pi over 3. Let's say I wanted to go 2 times around the circle, so I'm going to add 4 pi to it. Okay, so that's going to be what? 12 pi? That's going to be 13 pi over 3. So you're saying, okay, well this is all great. I'll multiply by 1/2. And I get x equals 13 pi over 6. But see, that's too big. 13 pi, that's more than 2 pi. So this one's not going to work because we're restricted between 0 and 2 pi. So because of the restriction on the domain, we can't use that one. So you can't go too many times. You can't just keep adding 2 pi and stay within the domain. We could do it once. We did it once here, and we were okay. So you might say, well, how many times am I going to go around the circle then? It depends on this coefficient. If you've got a 2x, then you're going to go 2 times around. If it's a 3x, you're going to go 3 times around. If it's 5x, you're going to go 5 times around. Okay? And that's how that works. So, so we have our solutions. We had this one, pi over 6, and 5 pi over 6. We also had a solution here, 7 pi over 6. And then there was another solution when we had 2x equals 5 pi over 3. We're going to add another time around the circle, 2 pi. So that's going to make it, run out of room, 11 pi over 3. But then we've got to divide by 2 or multiply by 1/2. And then that's going to give us 11 pi over 6. And so we actually get 4 solutions here. They're all between 0 and 2 pi, so that fits the domain that we have, and they all work. If you think about putting each one of those in, what's going to happen? Well, you're going to multiply it by 2, and that's going to make it the angle you want. And then all of their cosines are going to equal 1/2. So you could play around with it a little bit more, but that works. And again, you might be saying, well, why didn't you just use a double angle formula? And we could. It would work fine that way. But we're showing you another technique in case it wasn't a double angle and it was some other, coefficient in there. You could use this technique.